The final integration we look at is by integration by parts and using tables of integrals. And this will happen when things get a little bit messy. So let's take x ln x dx. Okay, so it looks like a couple of functions going on here, but we don't have a u and a du. So this is a case where we are going to have something of the form u dv. And so let's take the more complex of the two to be ln x, and then dv will be x dx. So here we've got, if we rewrite this, ln x times x dx, we have u times dv. And what we're going to end up with is the integral of u dv equals u times v minus the integral of v du. Now all we have to do is, we've got u and we've got dv, we just have to figure out what du and v are, and we can just sort of plug and chug. So the derivative of ln x is 1 over x dx. And then to find v, we take the integral antiderivative of x dx, and we get x squared over 2. And now we're off and running, so derivative of u dv equals u times v minus the integral of v du. Simplifying things here, we've got 1 half x squared ln x minus, canceling an x here and down there, we just simply have 1 half x dx. So we have x over 2, we can bring the 1 half outside. And that gives us 1 half x squared ln x minus 1 half x squared over 2, all of that, plus a constant, and our final thing, we've got 1 half x squared ln x minus 1/4 x squared plus c. If we want, we could simplify that a little bit. 1 half x squared times ln x minus 1 half plus c. Or if we keep it in this form, this allows us to check our answer using derivatives that we know. So using product rule, we've got derivative of the first, 2 times 1 half is 1 plus x. First times the derivative, or the derivative of the first times the second, plus the first times the derivative of the second, minus 1 half x plus c. And this term ends up being 1/2 x minus 1/2 x. So these cancel, and we got derivative of the constant is 0. We got x ln x. That's what we have up here. Let's go to another one. We've got, we'll take 6x e to the 7x dx. What we can do, since e to the 7x dx has a relatively easy integral, I'm going to take u, 6x, du will be 6 dx. And so dv is going to be e to the 7x dx. Finding that integral, we would get 1/7 e to the 7x. And again, we can check that. Derivative of e to the 7x is e to the 7x times the derivative of 7x, which is 7, multiplied by 1/7 is just 1. So we have u dv, the derivative of u dv equals u times v minus the integral of v du. In this case, u times v minus the integral of v du. And actually this turns out to be not too ugly, so we can simplify the first term. That's 6/7 times x e to the 7x minus 6/7. We could bring the integral out here, or sorry, we can bring the 6/7 outside the integral here. And then to find this, the integral of e to the 7x, that's just (1/7) e to the 7x plus c, or 6/49 e to the 7x plus c. And again, we can check our answer here. So using the product rule and the chain rule, we've got the first term, the derivative of the first times the second plus the derivative of the second times the first, and then the derivative of the e to the 7x. And this constant is 0. So we have 6/7 e to the 7x. This term here, canceling 7 on top and bottom, we get minus 6/7 e to the 7x. And this 7 and the 7 cancel, we get 6x e to the 7x. With those two canceling, we get 6x e to the 7x. And then the last one we're going to look at is something using our integral tables. So let's say we've got the, let's find the integral of this. Well, we've got u du, I don't know, u and dv. This might get a little sloppy with the fraction here. So let's see if there's anything like this in the integral tables. And let's say I can see that 9 is 3 squared. So I've got 3 over 3 squared minus x squared dx. So we can look at our table of integrals. there anything that matches here? We can look through. I've got fractions here. This is integral of fractions. No, 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 no. Let's see. Oh, here's one. Here I have the integral of a over a squared minus x squared dx, which is what we've got here. So what's going to happen is a will equal 3. The integral is going to be 1/2 ln absolute value of x plus a, x minus a plus c. And that's a simple way to do it, looking at our table of integrals. And it's simply a matter of looking at the form of the integral you have and seeing if it matches up with anything in the table.